Good morning, students. Welcome to Good Samaritan School online classes. In the last classes, we were discussing on the introduction of this chapter light, and also we learned some of these very important concepts like reflection of light. What is refraction of light? What is light? Laws of reflection and spherical mirror, especially the two types of spherical mirror that we have learned, and some of the terminologies like uh, we have learned the pole, what is center of curvature, and what is radius of curvature, principal axis, and all these things we have learned in the last class, right? And today we are going to learn on the principal focus. What is the principal focus? The principal focus is nothing but the point on principal axis where the ray of light incident on the mirror parallel to the principal axis converges or appear to converge. Okay, let us even learn more on what is principal focus. Let's take an example of a concave mirror. So in this concave mirror, okay, just I have taken a concave mirror. You all know that the concave mirror is silvered inside. Okay, so and this is going to be there. What is this? P represents pole, right? So here the point on principal axis where the ray of light incident on the mirror parallel to the principal axis. You all know that this is what the principal axis, right? So in this in the last class we have learned about the principal axis. What is that principal axis? As we know that this is a spherical mirror, so it is somewhat like this, and we have a center of curvature somehow here, and the line joining the pole and with the center of curvature is said to be the line. This line is said to be the principal axis, right? So what it says, the ray of light incident on the mirror parallel to the principal axis. So the ray should come like this, parallel to the principal axis. So here the rays will come like this. Here also the rays will come parallel to the principal axis. Okay, so what it comes parallel to the incident on the mirror parallel to the principal axis converges. You have to know one thing, concave mirror is another said to be a converging mirror. That means all the rays converges at one point. Okay, where it converges, let's see that. This is the ray where it comes incident and then it converges. So it converges somehow here. And this ray also converges. Where it converges? At one point. And this ray also converges here. So converges. And this is also. So once it is all converging, it converges at one special point. Okay, so this ray parallel to the principal axis incident and then it converges here. Okay, and it started to come at one point, right? And this point we name them as principal focus. So we write it as F, and this we all know that it is C, center of curvature. So the line which is the point which converges, or the point which joins all the converging side, or converges all the rays, is said to be the principal focus. Will you all understand here? Right, same thing you can do for convex lens also. As we know that convex lens is a diverging lens. Diverging means this is also having a spherical mirror, right? So the shining side, the silver side is here only. This is the pole, and so it is having a center of curvature here, somehow here, right? So once all the rays from here they started comes, okay, the rays are all coming here and hitting, then what happens? You all know that once they come and hit the mirror, they all get reflected. Am I right? So most of the rays get reflected. So this ray get reflected here, and this ray get reflected like this, and this ray get also reflected like this. But when we extrapolate these rays to the other side, it should come like this. So it should come like this, and this ray will become like this, because most of the rays are getting reflected in convex lens, but we are extrapolating this rays. So all these rays will also come at one point, and this point is said to be the focus. And what focus? This is said to be the principal focus. So this is how it forms. The principal focus is nothing but the point on the principal axis where the ray of light incident on a mirror parallel to the principal axis converges or appears to converge. And here it definitely converges. You see that. In concave mirror, all the rays comes parallel and converges at one point. But here it is not converging. Most of the rays are getting reflected. Once the incident rays comes and hit the convex mirror, most of the rays get reflected. All the rays get reflected. But it appears on the other side, if you see the extrapolate of these lines, put an extrapolate of this line, it appears to converge, but it's not on the other side. It converges on side this. That's what here this talks about the um, convex lens. This is what happens on the convex mirror. The next topic is focal length of the spherical mirror. Okay, what is focal length? Focal length, what is focal length? It is nothing but the distance of the principal focus from pole of the mirror, right? So you can see that this is the pole of the mirror. So we have taken a concave mirror here, and this is what's said to be the pole of the mirror, right? The distance between the principal focus, as we know that all the rays which is comes from the incident ray comes parallel to the principal axis, and it hit the mirror and then all converges at one point, and that point is said to be the principal focus. That is what we have learned. So the distance between this principal focus and the pole, and this distance is said to be the focal length. Okay, so what is focal length? Fp is equal to f. This small letter f talks about the focal length. This can be this we can write it for even convex also, as we can write it for convex lens also, sorry, convex mirror. So we can take a convex mirror like this and then put a line, and this is what said to be the pole, and as we know that this is going to be the center of curvature, and this is how we can write all the incident rays come and hit the convex mirror and get reflected, right, and get reflected. But when we extrapolate these rays, they all come at one point, right? These rays come at one point, and this is all said to be the focal, right? This is what we can name them as a principal focus, right? So the distance between the principal focus and the pole, and this is said to be the focal length, okay, for a convex. So here we are going to see one more thing in this topic, the relation between the focal length and the radius of curvature. So what is the relation between these two? As we know that the focal length is represented by, yes, f, and the radius of curvature is, yes, r. So what is the relation between these two? The relation is nothing but r is equal to 2f. That means the radius of curvature is twice the size of the focal length. So I can see that this is a concave mirror, and this is the center of curvature, and this is the focal, this is the principal focus, and this focal length is nothing but the distance between the f and the p, right, is actually 2f, 1f and 2f. That's what we say, that the radius of curvature r is equal to the 2f. So to prove this, we have a even we can prove this by using one theory that also we can do it in this class. Let's take a concave mirror. So in this concave mirror, so here this is the mirror, so we can take it as a pole, and this is going to be the center of curvature, and this is the focal or principal focus. Okay, we can take it like this. For examples, take some example. The ray of light which comes parallel to the principal axis, and then they get reflected towards the principal focus. Okay, like this. So what happens, somehow, not only this, if I take some rays which will also come towards the center of curvature. So here we form two different types of triangles. So what I'm going to take this as a and the line which is joining here, which is taken to be a B. Okay, so here there is a triangle which is formed between A, F, B. So and also the triangle between A, C and B, right? So two things, the A, B, C, one is sorry A, B, C, another this the A, B, F, A, B, C and A, B, F. So the angle formed between A, B, C is theta, and also the angle formed between ABF is 2 theta. You just take it as example. Theta is actually a small angle, right? And here also there is an angle formed between them is theta, and here also there is an angle formed between. These are the very small angles they form. Take some example. Okay, we have two triangles are there. So why what we are doing it here, because we are proving how this formula comes, r is equal to f. Okay, that is what we are proving here, but this is not coming for your exam, but we are learning what is how it happens. Take a triangle ABC. So if you know that tan theta you all know that it is opposite by adjacent. So what is opposite? This is the triangle here. So AB by BC. So in this triangle ABC, tan theta is equal to AB by BC. And we have another triangle, that is in this ABF, we have tan 2 theta. So here it is tan 2 theta, which is equal to, again here also AB and BF, AB by BF. So since the theta here, theta is very small, so we are writing it as tan theta is just approximately, we can write it as theta itself. We have no need of writing tan thetas and all. So what it comes here, so theta is equal to AB by BC, so we can take it as our first equation, and 2 theta which is equal to AB by BF. Okay, so from this two equation, so what we are going to write here is from 1 and 2. So we are making it as, because both are AB actually, theta is equal to, if I cross multiply this, it comes theta into BC, and if I cross multiply this, 2 theta into BF, right? But both are is equal to AB only, so we remove that AB, and since we write it only this, theta into BC is equal to 2 theta into BF. I think you can understand this. If I cross multiply this, both is equal to AB, so we write it as same. So theta, 1 theta get cancelled, so we find this as, this is BC, where this BC here, BC, right? And another is BF, where is this BF here, BF, and there is a small distance between here, it is BP. So since it is small distance, so we can remove this b and we can join with p itself because it's very small. So we can write it like this as a pc, which is equal to 2 into pf, right? I hope you can understand this. So what it comes here, what is pc? pc क्या है? It is nothing but, yes, I hope you can understand this. The radius, right? PC is the radius of the curvature. So we write it as R. So is equal to 2 into PF. What is PF? Yes, this is the focal length F. So we write it as F. And this is how it was proved, and this is what used as the formula to find the relation between the focal length and the radius of curvature. Our next topic is how the image formation by the spherical mirror. The image formation by the spherical mirror. Just see that. The rays originating from the point actually meet at another point after reflection. That point is the image of the first point. So we have two different types of images. One is the real image, second is the virtual image. The real image is nothing but the rays actually meet. The virtual image is nothing but the rays appears to meet. This is what we have learned in concave and the convex lens. I just want to show it once again. Here you can see the difference between the real image and the virtual image. In concave mirror, all the rays which comes here parallel to the principal axis and joint at one point, right, converges at one point. This shows a real image. Okay, because it's really converges, actually meet. You see that all the rays actually meets here. But in concave, you see that they are not actually meeting. All the incident rays, they get reflected. They are not meeting. They just go somewhere else. But when we extrapolate the rays to the other side, there it meets at one point, and that we name them as a principal axis, we name them the principal focus, and in other word, the distance between these two are said to be the, yes, the focal length. So what we are learning here is, here it is not meeting really, it meets at the other side where it is not really meet. So this kind of image which is formed here is said to be the virtual image. I hope you understand this topic. So here we are going to see the same kind of thing. For example, if a boy is standing here in front of a mirror, you think that in front of the mirror, like a plane mirror, so what it finds, the same image will be appeared in the other direction. Same size, same will be there. You think of the same boy who stands in front of a convex mirror. We all know that convex mirror, you can't see the same type of an image. थोड़ा छोटा आप देख सकते, diminished images. But the boy, this is one thing, this is another thing. If a boy stands in front of a concave mirror, then he appears to be little bigger. The image little थोड़ा बड़ा देख सकते आप. So all these things you can see in the if you see all these things changes, you can see in the spherical image. These are the images that formed on the spherical mirror. The topic we are going to see now is the image formation by the spherical mirror. Some of the rules which is essential in the formation of the spherical mirrors. Okay, the first rule is, whenever a ray of light is incident on the mirror parallel to the principal axis, it passes through the principal axis. Okay, let's draw this and we will understand this. So I have taken two lenses here. One is the concave, another is a convex mirror. Sorry, I'm just, sometimes I used to tell as lens. It's not lens, actually it is a mirror. Okay, so all these are mirror. I have taken concave mirror and the convex mirror. And as we know that they have a pole, a center of curvature, and the principal focus. Here also they have a pole, principal focus and the center of curvature. So when the ray of light which is passes parallel to the principal axis, that's what here it says. Whenever a ray of light is incident on the mirror parallel to the principal axis, it passes through the principal axis. What is the principal axis? Yes, principal axis is this. Yes, here it passes through the principal axis, right? Same thing you can see here with the convex mirror. When a ray of light which is passes, it comes through parallel to the principal axis, and what happened in convex mirror, they get reflected, right? But if you join the line which is coming on the other side, you can see here it is coming towards the principal axis. So this is how it forms. So when a ray of light is incident on the mirror parallel to the principal axis, it passes through the principal axis. Same thing, it gets reflected, but when we extrapolate the rays, it definitely comes on the principal axis. This is rule number 1. Let's see rule number 2. The ray of light which passes through the principal focus towards the spherical mirror, after reflection, the reflected parallel to the principal axis, just an opposite of what we have learned before. So first it should come towards the principal axis, the reflect incident ray, and then get reflected to the parallel to the principal axis. Same thing you can see for a convex mirror also. First the ray of light which comes, yes, which is coming here, and then after reflection it goes parallel to the principal axis. The ray of light which passes through the principal focus towards the spherical mirror, after reflection it reflected parallel to the principal axis. Once it comes here and goes as a parallel. Okay. The third rule is the ray of light which passes through the center of curvature of the spherical mirror, after reflection it retraces the same path, that is, goes back along the same path. That means the third rule talks about when it comes towards the center of curvature. This is center of curvature. I think that the ray of light which comes here through center of curvature and it goes back in the same line. Same thing you can see here, the ray of light which comes here whenever we are writing drawing for a convex mirror, you have to use this extrapolate rays. So it comes and goes in the same way. Okay. The last rule is the ray of light which is incident towards the pole of the spherical mirror oblique to the principal axis is reflected obliquely. How this has happened? When the ray of light which is incident towards the pole of the spherical mirror, where it exactly comes on the spherical mirror obliquely, and then it's reflected obliquely in the same length. This is what we know about the when it incident rays and the reflected rays comes on the same angle. Same thing you can see for convex mirror also. When it comes, the incident ray comes at one direction with same axis or same angle, it reflected on the same angle itself. That's what here it says, the spherical mirror obliquely to the principal axis is reflected obliquely. So these are the things we have learned today, and today we have learned a little more topic. One is we have learned on principal focus and also about concave and the convex lens mainly, and then focal length of the spherical mirror also we have learned, and the relation between the focal length and the radius of curvature that we have learned, and also some of the set of rules to form the image on the spherical mirror. This is the end of the class, student, and if you have any doubt, please do ask me in my WhatsApp number. Thank you and have a nice day.